Students, welcome to the lesson. Our today's topic is equilibrium. When different forces are acting on a body, and under the action of these forces, a body is either at rest or it is moving with constant velocity, we say that the body is in equilibrium. Students, there are two types of equilibrium. One is called static equilibrium and other is called dynamic equilibrium. Now let us discuss them one by one. Static equilibrium. As I told you, when under the action of different forces a body does not move, we say that the body is in static equilibrium. Look at these diagrams. In first case, a block is lying on the table. Two forces are acting on the block. One is its weight acting downward and other is the reaction of the table acting upward. Under the action of these two forces, block is not moving, it is in static equilibrium. If a body is hanging, two forces are acting on it. Its weight is acting downward, tension in the string is acting upward. Under the action of these two forces, the hanging body is at rest. We say that it is in static equilibrium. Similarly, in tug of war, when two teams pull a ring on opposite sides and if ring is not moving, it is in stable static equilibrium, although two forces are acting on it. Next is student dynamic equilibrium. When there are different forces acting on a body and under the action of these forces a body moves with constant velocity, we say that it is in dynamic equilibrium. Look at the example of a moving vehicle. Two forces are acting on it. One is the driving force, that is the force of engine, and other is the opposing force, that are the forces of friction between rod and tire and air resistance. Under the action of all these forces, car is moving with uniform velocity. We say that it is in dynamic equilibrium. Similarly, when a paratrooper is falling with constant velocity, two forces are acting on it. Air drag is acting upward and its weight is acting downward. Under the action of these two forces, it is falling with constant velocity. So it is also the example of dynamic equilibrium. Now students, we see what are the different conditions for a body to satisfy to be in equilibrium. There are two conditions of equilibrium. They are called first condition and second condition. Let us take what is first condition. It states that according to first condition of equilibrium, sum of all the forces acting on a body should equal to 0. Students, you know force is a vector quantity, and when we add forces, we also consider their directions. For a body to be in equilibrium, it must satisfy this first condition that all the forces acting on it should give 0 resultant. Look at this diagram. Two forces are acting on it. Both are equal in magnitude of 10 Newton, but they are acting in opposite direction. When they are added, they will cancel the effect of each other. So body is in equilibrium, satisfying first condition of equilibrium. Sometimes first condition is satisfied, but body is still not in equilibrium. It means that there must be another condition for a body to be in equilibrium, and that is called second condition of equilibrium. According to second condition of equilibrium, sum of all the torques acting on a body should equals to 0. Means clockwise moment or clockwise torque should balance the anti-clockwise torque for a body in equilibrium. Look at this diagram of a seesaw in which two masses are placed on the opposite sides. One's weight is 15 Newton and other's weight is 19 Newton. One's distance is 6 meter and other's distance is 4 meter. You know this distance is called moment arm. Students, seesaw is in equilibrium. It is satisfying this second condition of equilibrium that says sum of all the torques acting on a body should equals to 0. Now look at the diagram. The torque acting on the left side is obtained by multiplying 4 with 15, means force with moment R. And similarly, torque on the right side will be obtained by multiplying 6 with 10. So it is torque on the left side, it is torque on the right side, and when they are calculated, we say that both the torques are equal, but they are acting oppositely. When they are added, they will cancel the effect of each other, so body will be in equilibrium. So these are the two conditions of equilibrium. Number one, sum of all the forces acting on a body should equal to 0, and sum of all the torques acting on a body should equal to 0. Now we come to states of equilibrium. There are 3 states of equilibrium according to center of gravity of a body. You know, center of gravity is a point inside the body at which the whole weight of the body acts. So according to the position of center of gravity of the body, there are 3 states named as stable, unstable, and neutral. Let us take them one by one. Stable equilibrium. Students, if after removing the disturbing force, body returns to its original position, means when a body is disturbed and when this disturbance force is removed, and if body returns to its original position, we say that the body is in stable equilibrium. Look at this diagram. When this block is disturbed by applying some force, and when this disturbing force is removed, it will come back to its original position. We say that this block is in stable equilibrium. Another important thing to note here is, when this block is disturbed, what happens to its center of gravity? Its center of gravity rises from its original position. And when the applied force is removed, this center of gravity, means the torque produced by the weight of the body, will bring the body back to its original position. So it is the situation in which the body is in stable equilibrium. And in case of hanging bodies, body will be in stable equilibrium if it's hanging such that its center of gravity is lying below the point of suspension. Point of suspension should be higher than the center of gravity. And when such a body is disturbed, simple example is the example of pendulum. When it is disturbed from its mean position, it returns back to its mean position due to its weight, due to torque produced by its center of gravity. So it is the example of stable equilibrium. In case of hanging bodies, the situation should be center of gravity should be lower than the point of suspension. Next is unstable equilibrium. If after removing the disturbance force, body does not return to its original position, we say that the body is in unstable equilibrium. Look at this vertically standing pencil. When we disturb this pencil, it will fall and will not come back to its original position. Now again, look at the diagram. What happens to its center of gravity when it is disturbed? Its center of gravity gets lowered than its original position when the body is disturbed, and the body cannot return to its original position. Such an equilibrium is called unstable equilibrium. And in case of hanging bodies, if center of gravity is above the point of suspension, then the body will be in unstable equilibrium. Look at this diagram in which an acrobat is walking over a tight rope. Its center of gravity is above the point of suspension. Point of suspension is where its feet touch the wire. So its center of gravity is above, and when it is disturbed, it will fall down. It is an example of unstable equilibrium in case of hanging bodies. Similarly, third is neutral equilibrium. If a body is disturbed and undisturbing, although it gets new position, but its center of gravity neither rises nor falls from its original position. Such an equilibrium is called neutral equilibrium. Best example is a ball. When we hit a ball, it rolls some distance on the floor and comes to rest. However, the position of its center of gravity from surface of the earth does not change. It is an example of neutral equilibrium. Similarly, in case of hanging bodies, if the center of gravity of the body is at the point of suspension, when such a body is disturbed, it gets new position. Look at the wings of this windmill. They are fixed here, and here is their center of gravity of this fan. So when we disturb it, the fans may get new position, but their center of gravity will not change its position from the surface of earth. So it is the example of neutral equilibrium in case of hanging bodies. Students, let us at the last we see how to increase the stability of a body. Means how to defend a body from falling. More stable a body, more difficult to fall it. Now, to increase the stability of the body, we must increase the base area. First step that we can take to increase the stability of the body is to increase its base area. Look at this diagram. Here is a body A whose base area is less, and here is the body B whose base area is more. So B is more stable than A. A little push can make A to fall, but it is difficult to fall B. So stability of B is more than stability of A. The second step that we can take is to lower the center of gravity of the body. Look at this diagram. A is a tall body, tall vehicle, tall building. Its center of gravity will be at larger distance from the surface of the earth. So it is unstable as compared to another vehicle whose height is less. Height less means center of gravity is lower and close to the earth. So in this case, the position of center of gravity in body B is lower. So body B is more stable than body A. That's why the sports car are made flat to increase their stability. Or we can take both the precautions. We can take both the steps. We can make the center of gravity low, and as well as we can increase the base area. In this case, both the steps are taken. One, we made the position of center of gravity low, and secondly, we increased the mass, made the body be more broader. So B is more stable than A. So students, this is all about equilibrium, types of equilibrium, conditions of equilibrium, states of equilibrium, and how we can increase the stability of a body. Students, thank you very much for sparing your time to watch the video. If you liked the video, don't forget to subscribe the channel. Take care of you. Goodbye.